Okay, a prerequisite of this video is the change of base formula. So if you haven't already seen my video on that, I recommend that you watch it now. To solve a logarithmic equation when different bases are involved, we have to begin by rewriting all the logarithms using the same base. So let's choose to rewrite this log base 9 of x using base 3. Okay, so we get a log base 3 in the numerator and the denominator. Again, 3 because that's the new base that we're choosing to use. X, the input of the old log, goes to the input of the numerator. 9, the base of the old log, goes to the input of the denominator. Okay, so now we should clean up this right-hand side. So let's take a look at this denominator, log base 3 of 9. The value of that is the power to which we must raise 3 in order to get 9. So that's 3 to what power gives you 9? The answer is 2. 3 to the second power gives you 9. Okay, so now we have to continue to rewrite. Okay, dividing this log base 3 of x by 2 is equivalent to multiplying by 1/2. Okay, so now what we need to do is we need to take this coefficient of 1/2 and pop it up as an exponent. Okay, now we're ready to get rid of the logs. Log base 3 of x minus 6 equals log base 3 of x to the 1/2 means that x minus 6 must equal x to the 1/2. That's the only way that the log base 3 of each of those can be equal. Okay, x to the 1/2 is really the square root of x. Okay, so to solve for x, because we have a radical equation here, what we have to do is we have to square both sides of this. X minus 6 quantity squared is x squared minus 12x plus 36. Okay, you can get that just by foiling x minus 6 times x minus 6. And that's equal to the square root of x squared, which is just x. Okay, now what we should do is we should bring this x over to the other side. So we subtract x from both sides. We get x squared. Negative 12x minus x is minus 13x plus 36 equals 0. And now we should factor. So x squared minus 13x plus 36, that factors as x minus 4 times x minus 9. Okay, so x minus 4 times x minus 9 equals 0, so that must mean that x is either equal to 4 or 9. However, we're not done yet. When we have logarithmic equations, we have to check for extraneous solutions. Okay, so what that means is even though it appears that 4 and 9 are solutions, they're not necessarily solutions because they might not solve the original equation. So let's check these with the original. Okay, so here's the original equation. Okay, so let's check x equals 4. So we plug it into the left side and the right side, and they both need to be equal. Log base 3 of 4 minus 6, well, that's log base 3 of negative 2, and that is undefined. Okay, so we know that x equals 4 is not a solution. Now let's check x equals 9. So the question is, does 9 minus 6 is 3, so log base 3 of 3, does log base 3 of 3 equal log base 9 of 9? And the answer is yes, because log base 3 of 3 is 1, and log base 9 of 9 is also 1. So x equals 9 is the only solution to our logarithmic equation.